Alright folks, chapter 5. We are just about done with the coding portion of the book. I think there's one more chapter and then it just talks about projects and some other really cool stuff. So if you get through this and then chapter 6, you are home free. At that point we're just making projects and kind of fine-tuning things. So at this point, let's talk about object-oriented programming. If you've never heard that term before, it just means we're thinking about problems in terms of objects, which means an object has properties. It has size, shape, color. There are things about it. For every problem or every variable, there are same thing, properties. They also have behaviors, like a door can open and a door can close. But there are some things that it can't behave like, so it can't drive a car. So when we say object-oriented programming, it just means we're breaking everything down into its smallest object, and then we're coding that object. Now they introduce some new terms in the book. One's called modeling, and this is just where you examine the object or the problem that you're trying to solve, and you determine its properties and behaviors. So we call that process modeling. Now, in Swift, objects are expressed using a class. And now when I say objects, I'm talking about like if we were going to, like for your book example, make doors and windows and things like that. Those would be objects. So we create a class to house all the different properties and behaviors of those objects. And we also use methods, and a method is just a function inside a class. Anytime you put a function inside a class, it gets a new name, and then we call it a method in Swift. So we create methods to define kind of the behaviors of objects. You know, the door can be open, the door can be closed, the door can be locked, the door can be unlocked, that kind of stuff. Alright, so here's an example of a basic class. So we do class, new door, and then we declare our variables, and then we create any methods that we need. So in this case, we're creating a class called new door. And then I've got several functions in here, but remember a function inside a class is called a method, which gets confusing. But so I can open the door, I can close the door, I can lock the door, or I can unlock the door. All right, and sadly these are screenshots, so you will not be able to just go back. You will not be able to copy these and paste them into your playground. But I will include the playground file in this chapter. I take it all the way up to the first subclass of a subclass. I'll let you know where my stop point was. But you get the idea. So a class is just, hey, you know, I'm creating a new door. Here's the variables the door is going to have, or the properties. The door can be locked, unlocked. It can have a width, a height, a color, a weight. And then I can do behaviors with the door. So properties of the door come in our variables, and then functions of our door or behaviors of our door are methods. So once we create that class, in order to call objects in the class, we just say, you know, let front door. First of all, typically they give it an alias first. So in this case they do let front door equal door. So now I'm going to create a new variable called front door, and it's going to reference the class. And then I can say front door dot open and front door dot close. Now in the parentheses I don't have anything because there's no variables needed. You know, this isn't a math problem where it requires input. You know, it just, hey, I'm going to open it, I'm going to click on the open function, I'm going to click on the close function, I'm just going to get text to the screen. So I don't need to include anything in those brackets. Now, why do I typically give it an alias? Well, if I just use the word door, and I don't give it an alias like front door, then I'm already filling up the variables for the class, and I can't use the class again unless I overwrite those variables. So I can't have a front door and a back door if I just use the word door as the first one. So that's why we give it an alias, so I can have a bunch of instances of the class, if that makes sense. Alright, when you're creating a class, you also need to pay attention to your methods. And you want to user proof it. Your users will not listen to the directions. They don't read the text. They will try to lock and open door. They'll try to unlock and unlock door. You ask them to put in a number 1 to 10. They'll put in 11. That kind of stuff. So we need to build that kind of logic into your code. An example of this is here. So in the functions, we got the normal part. So if opened equals false, then do this. And then say, hey, so it's not opened, so now I can open the door. And then set the to open equals true. But if opened is already true, it'll say the door is already open. So if the user tries to open an open door, it'll say the door is already open. So you typically want to put some stuff in your code so that when the user does something stupid, they get the message that says, hey, you're stupid, don't do that. Alright, so let's say you want to change the variables inside your class. Now, if you've created the variables using the word let, you can't change those because those are constants. So you need to use the word var. So just go back to your class and you can change it with the word var. So I have all my variables as vars instead of lets, and I'm all set. No, I'm not on technique 2 yet. But so then I can give the class an alias, then a dot, and then the variable I want to change. So back up here, what was I going to change? I'm going to change the width. So if I look, my width right now is 32. So that's where it is in my initial class. So if I want to change that, because now I made a front door, which is a different size, I give it an alias, which I did with front door, dot, and then the variable that I want to change, so front door dot width, and then the new value I want to put in. So front door dot width equal 36. So that's the ghetto technique. If you've got just a few things you're going to be playing with in the class, and there's only going to be a few aliases of the class, you can kind of get away with that. But method 2 is you create an INIT, which is a special method for a class. And this allows us to make several doors of different sizes in the program instead of just one that's kind of hard-coded to the class. So here's an example of that. So I add this line here, int, and then I put some defaults in. So width equal 32, height equal this, weight equal that, color equals red. And then you have to decide, what the variables' names are going to be. So what am I going to call width, height, weight, and color? Well, in this case, I still want to call them width, height, weight, and color. For some reason, you might not want to call them that. So throughout our example, we want to call the int variables the same name as the class variables. So the int variable of width is going to have the same name as width, which is the class variable. So we're going to put self dot in front of that, and then we can still just use the same names, which most of the time that's what you're going to see out there. It just makes more sense to call it width, height. If you're going to program Angry Birds and you're going to make a class for all the different birds, and you're going to have a variable called jump height, why would you ever change that? I mean, what would you change a jump height to where it makes as much sense as jump height? So I know how far I can jump or something like that. So we typically just put self in front of that. So that's the only thing you have to add, and now I could easily pop in new stuff in there, and I'm all set. So you only have to put the properties in there. Remember, a door has a property, and a property is width, height, weight, and color. Things that we can use to describe it. But things that it does are behaviors, locked and unlocked. So I don't have to put locked and unlocked here in my code or in the int method. Here's what they look like together. So if I was doing it, from the ghetto method, I would just make this var, and then I would just do my little code to change it. But if I want to put the int method in there, I can pop that in there, and I can still call everything width, height, weight, and color, and make changes. So now using the int method, I can make as many doors as I want. I can just say, hey, let new backdoor equals new door. So I still have to reference the class, and then I put in my variables, so the width, height, weight, and color, and then the new front door, and then the new side door. So that method just makes a lot more sense because there's a lot less kind of code I got to put in. Like I don't have to do front door dot width equals this, and then front door dot height equals this, and then front door dot weight equals this, that kind of stuff. So this is the preferred method. All right. So if you want to change a value, you just go type in the object name dot the variable name and then a new value. So if you're going to do just one new value, like hey, the new back doors, the color is going to be white, you can simply change that. But if you're adding a whole new object, it's a lot easier to do this method than it would be if I did the ghetto method. Now, that also assumes that you used var and not let when creating your class. So when you're creating your variables, your properties, make sure you use var. All right, inheritance. Your parent class can have properties that flow down into other child classes. So the parent class is typically called the base class and sometimes called the superclass. And then the child classes are also called subclasses. So you have a superclass that has all the main characteristics, and then you can have subclasses. And your book does a good example of this. So, like, I've got this class for a door that has open, close, lock, and unlock. But there are other things that I could use that on. I don't have to just use it on a door. I could use that on a window, because a window can open and close and have some of the same characteristics: height, width, color, that kind of stuff. So what I want to do is, rather than create a whole new class just for Windows, if I rename my class and call it something else, in this case the book calls it Portal, then I can have a Portal class with all these different objects and behaviors like open, close, lock, and unlock, and then I can have a subclass of doors and a subclass of windows. And then whatever properties they share, that can be created in the base class or the superclass. And then whatever specific properties are specific just to that one thing, like a window, being able to see through, I could add just to the window subclass. So in your example of the book, they kind of change it around. So now it's class Portal, and then everything else is still the same. But they add a name here so that I can give things different names. Like I can have a window, or I can have a door, or I can have the new door, stuff like that. So other than that, everything is still the same. So I just changed the name of the portal, same variables, and I changed it so I could add a name into my my initialization function. And then I have my initialization method. Say that 10 times fast. And then I have my same exact functions that are in there. Open, close, lock, and unlock. And then at the end of that, I pop in this, my two subclasses. So now I have class NiceDoor that links to Portal, and he has a width, height, and blah, blah. And then I have a class NiceWindow that links to Portal as well. So he can use the open, close functions. And then in the first line, I create the variables of NiceDoor. So NiceDoor is going to have this variable, this variable, this variable, this variable. And then they're going to reference in the superclass these variables. So these variables in the superclass are going to be referenced when I put in 32, it's going to go to width. And when I put in the height of 72, it's going to go to height. So that's how you kind of put that together. So this is just saying it's going to match to the superclass through these methods or through these variables. And then here I give my variables and I say then here's what they're going to line up with in the superclass. So now I can have a whole bunch of different subclasses, even if something only matches one thing. Like a drawer on my kitchen counter. It could still use the open and close functions. So rather than writing a class for drawers, I could just make a subclass of it real easy with a couple lines of code, and now he can already use the functions that are already there. Next week when we do our tip calculator, you guys are going to make a class inside there to hold your variables, and you'll kind of see how some of this stuff works out. So where could I use this? If I'm making a game, I could create an enemy class, and then all the different enemy characters in the game could be a subclass. So like I might make a class that has different hey, here's how hit points, and then here's the basic attack, and here's this, and here's that, and then I could have an enemy that adds one special thing or something like that. Or if I'm playing Angry Birds, I could make a bird class, and then all the different Angry Birds could all be subclasses. Or if I'm doing an application, let's say I'm making a lawn and garden application that gives information on different types of lawns. I might have all that information as functions, if grass is dry, water it. And then the different types of lawns could be subclasses that could also use that information. So you're going to see classes and subclasses used very heavily in code in your iOS apps. All right, so how do I call a subclass? Well, first I give it an alias, so let sunroom door equals NiceDoor. And then I referenced the alias in the method, so sunroom door dot close, and then that references the method, and I'm all set. So whenever we're calling a variable or a method or anything like that, we never use the method's name. We always give it an alias first because we don't want to use the method up and then just keep rewriting over it. We want to have multiple classes. If I want to have information on multiple doors, I can't just use the door class and fill it up. So we give it an alias first, so sunroom door is going to take over NiceDoor. And if you remember, NiceDoor was there, so here's our NiceDoor reference. And then NiceDoor.close. And then that goes to NiceDoor, and then NiceDoor is referenced to Portal in the code. So that's how kind of everything all matches nice and neat. Now again, in our case, we're not passing any values, so we're not doing any math programs or anything like that. So we have nothing in our brackets. Now if you had to pass variables into the function, like let's say it was a function that calculated Fahrenheit to Celsius, you would have to include those numbers in here so it could calculate the numbers for you. Alright, and if that's not confusing enough, you could have a subclass of a subclass. Woohoo! So in your book's example, they make a combination lock. So I can have combination doors that reference nice door, and then nice door references portal. So I have a subclass of a subclass. And then I might have windows, and I may have different categories of windows or subclasses of the subclass windows. Some windows are single pane, some windows are triple pane, some windows have gas locked inside the panes. So now I have all these different subclasses of window. So you can see where that would come in handy. All right, and then there's the override. Now, when we create a method that has the same name as another method, like in this case, we're going to use lock. There's still that method that's in the main class that I can lock and unlock a door just by typing in lock. Well, now we want to go to combination door, so we don't want to be able to use lock and unlock. So what we do is we override the function lock so that if somebody types in combination door lock, they can't use the one from the base class. They have to use this one. Just keep in mind when you do things like that, you typically have to do two. Like if I'm going to override lock, I need to override unlock. And if I need to override open, I need to override closed. That kind of stuff. So override just overrides the previous function and gives combination door its own version of lock that overrides the class function. And I think right after this example, that's when I quit typing into the playground in Xcode. So I will have the file up until this point saved for you, and it'll be in the materials folder. All right, so that is override. And then your book kind of talks about a couple other things, the convenience initializers. What a convenience initializer does, it allows you to create multiple instances of a method, one with default values and one that requires certain parameters. So in order to use convenience initializers, you typically make a designated initializer and then the convenience initializer. So as an example in your book, on page 140, they have class tractor, and tractor has horsepower and color. So then we have our designated initializer, and it has horsepower and color. And then we make convenience horsepower that requires horsepower and color green. And then we have this one here that pops. This one gives you the default. So the default for horsepower is going to be 32 unless you put it in on this one. So one method gives us defaults. One method requires the user to put something in. And then your book gets into enumerations. And enumerations just allow you to specify a group of related names with the intent of referencing those names in your code. So if I'm going to have a bunch of different tractors, and some tractors can be gas, biodiesel, diesel, or electric, I just create an enumeration type, and then I can reference it using the raw value. So let fuel characteristic equal fuel type dot gasoline dot raw value. And then there's an example of this on page 143. I don't think we're going to get into this very much in this class, so I'm not going to hammer it too much. And then they talk about structures. So they finish it up with structures, and they only give you like 2 pages of it, and they give you like one kind of crappy example. A structure is exactly like a class. So everything about it is almost identical to a class. The big difference is how it handles data. So a class handles data by reference, meaning when something in the class asks for a variable, it doesn't pass the value of that. So let's say the variable is x, and then something says, hey, I need x. Well, what the class does is it says, okay, here's the memory location of x, so you can look at the original value. So if somebody changes x, they actually change the value in memory, and then anybody else that references x, they get the changed value. Now you can see that obviously uses a lot less memory because there's only one memory location for the value x. So that's a class. A structure is different. A structure handles data by value, meaning the actual value is passed over. So if x is 5 and you ask for x, I'll just hand you 5 and you'll create a new memory location for your variable of x. So now I have 2 memory locations for x that both have the value of 5. But then you can change your variable and it won't affect the original variable of x. So it gets a little bit confusing, but obviously structures will typically absorb more memory than a class because you're just passing values and adding more memory locations to your program. Where by reference, there's only one memory location, but because you're doing it by reference, there's only one original copy. If somebody screws up the original copy somewhere in the program, then the rest of the program gets the screwed up copy. So both sides have their pluses and minuses. It all depends on what you're trying to do. Typically when we're coding, we probably try to code by class because we want to use as little memory as possible, especially for iOS. When we're talking about iPhones and iPads and that kind of stuff, they don't have the memory PCs have. When you're making a PC game, gaming PCs today have 24, 36, or 32 gigs of RAM in them. And that's not unheard of, where we don't get that on our iPhone. So we tend to do classes because they use less memory. All right, and that wraps it up. So remember, if you guys have any questions this week, I think for your lab, you just make a... Okay, so let's go take a look. All right, so if we go to your folder, week 6, your assignments. All right, you're going to create a class called Nice Cars, and you're going to have 5 variables: top, speed, price, color, model. And then under the variable section, you're going to create an INT section so we can have different cars. Then you're going to have a function that says if the top speed is over 120 mile an hour, print out vroom. If not, say something else, like this car doesn't go very fast. And then you're going to add a card in your code with a top speed of 150 so I can see that your function works. And then you're going to add a card with a speed of 100 to see what your choice prints out. Then when you're done, you're going to zip the entire playground and put it into the Dropbox. All right, then you also have a quiz. All right, that kind of wraps it up. Remember, we got to get this class thing down so that you guys can work on the tip calculator next week. And once we get through chapter 6 of the book, after that, it's all gravy. Then it's all like, modifying applications and talking about applications and actually building applications. So it'll be a lot more fun. So if you get through these first, 7 or 8 weeks, it's all gravy after that. And don't forget, for you guys, on the videos, I'm kind of covering this stuff kind of generically because there's so much information in the book. You can actually read through the book and probably get a better idea of this stuff than me talking about it. But if you have any questions, make sure you bring them up because I'm kind of hammering this stuff lightly because you guys all have Macs. Most of you guys already know most of this stuff already. So I don't want to bore you with a 50-minute lecture. But again, if you have any questions about any of this stuff, make sure you email me as close to the beginning of the week as possible so I can help you out so you've got time to work on your assignments. All right, we'll see you next week.